Howdy, howdy, this is Mr. Potter. In today's lesson, we're going to be talking about logical operators, relational operators. We're also going to be talking about operator precedence, and we're going to do these in situations where we're going to be testing and looping. So what's really nice is that the syntax for all of this is exactly the same as it is in C# or Java or most of the other C-type languages because they're emulating this structure. So I want to go ahead and write a program that's going to convert temperatures for us. So I'm going to go ahead and call this program temperature. So we'll do new file and we'll call it temperature.cpp. And we're going to go ahead and start up the way that we're used to. So I'm actually going to put a comment up here, temperature.cpp, so I know the file. I'm going to include, it's #include iostream, and I'm going to using namespace std, and I'm going to do my int main and put a return 0 in there. So what I'm going to do is I'm going to write a program that's going to prompt the user for a temperature in Fahrenheit, and we're going to convert it to several options where the user gets to decide this. So I'm going to need some type of variable where the user is going to be able to decide what option they want. So if we're dealing with Fahrenheit, I want them to be able to convert it to Celsius, I want them to be able to convert it to Kelvin, and there's an absolute scale that's based on the Fahrenheit scale called the Rankine scale, and we're going to be using that as well. So I'm going to have those three options, 1, 2, and 3, as well as if they type option 0, that will quit out of the program for us. So I'm going to declare a variable for my response, and I'm going to assign it a value of 4. Now this 4 is synonymous with any error condition, because if it's not a 0 or a 1 or a 2 or a 3, then I want to kind of say, hey, you entered an incorrect data, so we'll adapt to that. And I'm going to do this as a do-while loop. The reason I'm doing it as a do-while loop, just allows us to make sure that this gets done at least once. And this is a loop that's not actually emphasized as much on the AP exam, but it is an essential loop to know, especially when something has to be run at least once, but can be run multiple times. Now, what's important to note is that our loop control variable actually has to be declared outside of the scope because this while statement is outside the scope of these braces. So I'm going to need to make sure that to access response down here. So inside this loop, I'm going to create a variable for Fahrenheit, so double Fahrenheit. And I'm also going to prompt the user for it. So I'm going to cout enter temp in Fahrenheit. Semicolon. I'm not putting it in line because this is a prompt and I want their input to follow immediately. So at this point, they've typed in their Fahrenheit temperature and I've stored it in the variable called Fahrenheit. And so now I'm ready to tell them the options, what they have the choice for. So I'm going to cout and I'm going to tell them to choose. And I'm actually going to make this a multi-line cout statement. Just like in Java, just like in C#, the line of code doesn't actually end until it hits the semicolon. So I can insert white space, including spaces, including tabs, including new lines. So what I'm going to do is I'm actually going to make my cout statement look like, I'm going to make it look like what the output would be. So I'm actually going to do \t to tab, and I'm going to tell them that choice 1 is Celsius. And then on the next line, I'm going to tell them with a tab, choice 2 is Kelvin. And an end line. And then choice 3 is going to be Rankine. And then if they were to type in a 0, then that's going to be our quit option. And then I'm going to ask them for their choice. And then that's actually where I'm going to end this command. Now what I've done here is I've done a multi-level, a multi-line cout command. And I did it in such a way that my output here is what I'm going to see on the screen when I run this. So we're going to see this in just a few minutes when I actually run this. And now I'm ready to get the information from the user, so I'm going to go ahead and cn into my response variable. And why are you being picky like that? There we go. All right, so I have prompted for the user's response, and now I'm ready to calculate what I should get out of this. So I'm going to say double output. This is where I'm going to be storing the output. And I'm going to use a switch statement because the choices that I'm going to do, the formula that I'm going to choose, depend on which choice they make. Now I could use a series of if and else statements, but the switch statement is something that we used a bit in Java, and it's still a very viable option here. Based on the response, I want to do several things. If they type in a 0, then what I want to do is I really want to say, okay, the program is over, let's end it. So I actually want to get out of the switch statement, but I actually want to get out of this loop as well, so I'm going to type continue. Or actually just break. I'm going to deal with continue in just a little bit. If I get a 1, then I want to say that output is equal to whatever their Fahrenheit minus 32 is, times 9 divided by 5. Now it's okay that I'm doing integer arithmetic here because Fahrenheit, remember we originally declared it as a double. So the minus 32 will be promoted, the times 9 will be promoted, divided by 5 will be promoted because it does operate in order from left to right. So I will actually end up with a decimal answer. I'm not going to end up with any bad math. And we're going to go ahead and break out of that. Case 2, I'm going to say that output is equal to, now remember case 2 is our Kelvin, so it's the exact same formula. So I'm just going to copy it, but I'm going to add 273.15. Because remember that the Kelvin scale and the Celsius scale are spaced off exactly the same. The difference between the temperature points is exactly the same. It's just the 0 for it has been moved to absolute 0. And then we're going to break. And then for our case 3, this is our Rankine formula. Rankine runs exactly the same as Fahrenheit. It's just that its 0 has been set from the ice-salt water mixture temperature to absolute 0. So our output is going to be equal to Fahrenheit minus, plus 459.67. And then anything else, this is our bad input. So default, then I want to actually tell them, hey, you inputted something bad. So I want to cout improper input. And I actually want to tell them what their input was. So I'm going to print out response. And then period, try again. And then end line. And then I want to break. So I'm doing a switch statement here. Remember that our switch statement has the expression that we're testing, the response thing here, that in this parentheses, this is what we're actually testing. And we're testing it for these different cases. And depending on whether it's equal to 0 or 1 or 2 or 3, we're going to execute the appropriate line of code. I forgot to put a break here. Remember that each one of these case statements needs a break. The default statement really doesn't need a break because it's the last thing to be run, but if you put a break there, it's not going to hurt anything. So the switch statement actually gets through, and by the time I've reached this is the end of my switch. Once I've reached this part in my code, then I've got the calculated temperature, or my output is bad. Now, what I need to do is take care of some other stuff here. So if what they typed in was a 0, then what I want to do is I actually want to continue. Because if they typed in a 0, then I want to head immediately to my test and then reiterate through the loop again. If what they typed in was a 2 or the response was a 3 and the output is less than 0. So in other words, if all of this is happening, so if my response is 2 or 3, in other words, if they asked for Rankine or if they asked for Kelvin, and I ended up with a temperature that's less than 0, then I need to let them know that there's something going on here. So I'm going to see out, and I'm going to say this is a invalid initial temperature. And I'm going to tell them what that temperature was. So temperature. Actually, no, I called it Fahrenheit, didn't it? Fahrenheit. And then I want to say try again. Inline. And then at this point, I'm going to say else. So now I'm ready to go ahead and properly output the result. So I'm actually going to open braces here, and I'm going to make my output contingent on the switch statement. So I'm going to say cout converted temperature, and then I'm stopping here because I'm going to let the switch statement continue my output. So I'm going to switch my response based on the following. If they typed in a 1, then I want to cout whatever their output temperature was, and then put a C for Celsius, and then an end line, and then a break. In the case of 2, I want to cout output, and that means this was the Kelvin, and then I want to break. If they typed in a 3, then I'm going to be outputting using the Rankine scale, and I want to break. And then if they typed in anything else, and I've made it to this point, then this must have been one of my bad information. So my default is I'm going to tell them that it's impossible to determine. And end line. And I mentioned before I don't have to put a break there. This is the end of my switch statement. So that was an extra close brace. And this is going to be the end of my else statement, and this is going to be the end of my do while. So now I'm ready to put in my test. I want this test to run as long as they haven't typed in a 0. So if they've typed in a 1 or a 2 or a 3, I'm going to perform the indicated calculation. If they typed in any other number, then I need to let them know it's a bad number and give them another chance to do it. So I only want to repeat this while response is not equal to 0. And then, of course, I've got my return 0 statement here. So I'm going to save this. We're going to compile this. Remember, it's G++ and then our source code, temperature.cpp. And then I'm going to direct my output to temperature.exe. And hopefully I don't have any major ones. Oops, expected semicolon before switch on line 44, column 12. Remember I said that the compiler will actually give us the line number and the space number where it finds the error, but I do have to be careful because it's not telling me where the error is. It's telling me, hey, I found the error here, and it expected a semicolon before, and that's because I forgot to put a semicolon at the end of this line. So we'll save this and try and compile again. That works, so I'm going to run temperature. So I'm going to enter a temperature in Fahrenheit. So I'm going to put 98.6 degrees because that's body temperature. And I want to change this to Celsius. Remember our multi-line cout statement here. So what it's actually done is it's actually printed it out in this visual representation. That's why I used a multi-line cout statement here. And these escape characters that we're familiar with /t and /n and /quote, // those escape characters still work. There are going to be other ones that we're going to be using in this program, in this class, but for now it's fine to go with the ones we're already familiar with. So it tabs these over and it's ready for me for my choice. Well, let's see. I'm going to I typed in my body temperature. I want to convert it to Celsius. So I'm going to type in a 1 and it tells me that my converted temperature is 119.88 degrees Celsius. I think I have a slight fever. So let's figure out what we had here. Oh, that's right. It's supposed to be times 5/9, not 9/5. I'm an idiot. So let's try running this again. Oops. Quit. Stop it. Stop it. Quit it. All right, so let's go ahead and just get a new terminal tab here. This happens occasionally because I'm trying to use that shortcut where I hit up to do it. I need to recompile, so we're waiting for this to come up. So I'm going to do my compile. No, not file reader. I want to do temperature. Temperature.cpp with my output file being temperature.exe and then ./temperature.exe. Enter my temperature. I want to type in 98.6 and I want to convert it to Celsius and it converts it to 37. Wonderful. Let me do -40. If I convert -40 to Celsius, I end up with -40. And remember that these lines have different slopes. They have different scale between freezing and boiling. Fahrenheit has 212 degrees between Fahrenheit and boiling. Celsius only has 100. So because these lines have different slopes, these lines eventually should intersect, and they end up intersecting at -40 degrees. If I was to try -273 and convert that to Kelvin, it'll tell me that that's 103 degrees Kelvin. So I've got a pretty good scale here. If I do 459.66 and I want to convert that to Rankine, notice that that is 919.33 Rankine. And of course I can type 0 to quit, and that doesn't get me out though. I need to fix that. So I actually need to go back to my if response is equal to 0, then break. So I'm going to fix that. I'm going to quit out of this. I'm going to recompile and make sure that my 0 works. And my 0 is working now. What's important to note is that all of the logical operators that we are familiar with in Java, that we're familiar with in C# still work. As a matter of fact, Java and C# are based off of this C++ language. So when I'm using my AND here, I'm using OR. Those come from C++. So the reason that we learned them in Java and the reason we learned them in C# is because they came to us from C++. The syntax for the if statement or the if-else statement or the syntax for the switch statement, all of that comes from C++. So the fact that we could use these in Java or in C#, they came to us from C++. And all of the relational operators, where if I want to check to see if something's not equal to 0 or check to see if something's equal to 0 or less than or greater than, all of those come from C++ as well. So the logical operators, the relational operators, all of that stuff comes to us from C++ to the languages we've learned so far, and that's why this is such familiar code. As a matter of fact, the only thing that's different here is my outputs method, the way that I'm doing my output. Even the way that I did my calculations up here with minus and times and divide and addition, all of these arithmetic aspects are exactly the same. So, what's important to note is that C++, although it sounds like it's this very difficult language, we've been programming in Java, we've been programming in C#, so this is nothing new. The syntax is almost exactly the same. It's what we're familiar with. There's only slight tweaks. And as you proceed to learn more computer languages, you'll find that learning the concept is the difficult part. Learning the syntax is usually the easiest part. So, once again, this is Mr. Potter. Thank you for watching. Have a great day.